will propose to start our meeting. First, good morning and thank you very much that you attend today's training. Please, on the beginning, I have to tell you that we will make a record of this training. This record will be after this training resent to our all SIEUSOIL Communa, and we think that it will be next technology how to deliver our message, our new tools, and our description to all our SIEUSOIL population. Our training will be divided to two parts. First part, 45 minutes, will be covered by Plan for All. That is Czech member VP1 responsibility, including with Masaryk University, also from the Czech. And the main goal of this first part will be introduction of SIEUSOIL Hub. Second part will be led by Maria from Agrisat. Maria and her team also, yes. And this part will be or will cover a description of decision support system. And that's from my side all. Now I will request Hannah about the starting of her presentation. And colleagues, I wish you success in this presentation, and thank you very much. You could start.
Thank you for the word, Jaroslav. Can everybody see my presentation on SIEUSOIL Hub training?
Yes. Yes.
Thank you very much. So good morning and good afternoon, everybody, and welcome to SIEUSOIL Hub training. My name is Anna Kubíčková. I am from Plan for All, and I am here today, as Jaroslav already mentioned, to introduce you to SIEUSOIL Hub in the next 45 minutes. The agenda of the training will be as follows. Firstly, we will recall the goals of the SIEUSOIL Hub. Then we will move directly to the SIEUSOIL Hub and show what components and tools it offers. And finally, we will see those tools in action. More specifically, we will show how to create and visualize a map within the HSLayers NG and QGIS Layman plugin. In the end, I will leave room for your questions. If you have any question during the presentation, do not hesitate to use a chat, and we will answer them during the Q&A. Okay, let's start with objectives of the SIEUSOIL Hub. The SIEUSOIL Hub was established under the Work Package 1, and its main goal is to represent a modular, scalable, and extensible instance that may be integrated with existing solutions, primarily with the soil database of Europe and Asia as a part of the European Soil Data Center. The SIEUSOIL Hub should incorporate measured or observed or interpreted soil data, used or proposed models, and other relevant information and interconnect relevant soil data. In order for the SIEUSOIL Hub to meet the set requirements, it was necessary to find a platform that would enable the integration of the metadata catalog and the data visualization tool into one platform. And now it's the right time to move directly to the SIEUSOIL Hub and show how it was done. So let me please go there. Okay, so the SIEUSOIL Hub, as you can see it right now, is built on the Liferay portal that provides a robust platform to build a website on quickly and serve it to all clients, desktop, mobile, or anything in between. It provides all the standard applications which are needed, and it also provides an easy-to-use development framework for new applications or customization. So let's have a look at the catalog section, which is the first tab of the main menu. So the catalog section is called MITSCA, and it describes the available data, web services, and information sources connected to soil problematic, external sources of data, map composition created and usable in the map section, which is right here, are described also in the metadata catalog MITSCA. And now let's show the example. So for example, we can have a look at the data set called chemical properties at European scale based. As you can see, each data set, web service, and map composition is described by metadata, bounding box, and also links to data. Okay, if we go through the main menu step by step, the next step of the SIEUSOIL Hub is about the project, and this step leads directly to the SIEUSOIL Hub project website that all you are familiar with. And as the aim of the SIEUSOIL Hub is to represent all data as well as metadata related activities within and beyond the SIEUSOIL project, the introduction of users to the innovations of the SIEUSOIL pilots has to be an integral part of the Digital Innovation Hub. The overview of all SIEUSOIL pilots have been presented in the form of subpage website, and it's accessible right here. So let's have a look, for example, at Vito pilot. Okay, we are there. And the pilot subpage websites were designed to introduce innovation to Hub's visitors, a comprehensive picture of the individual SIEUSOIL pilot's context, provides pilots latest outcomes and actions, and also it allows stakeholders to interact with the individual pilots directly and keep them informed about upcoming events and pilot actions. Each of 11 SIEUSOIL pilots, which were defined in Work Package 7, are given a dedicated space to specify their location and describe the current situation and ways how to reach defined goals. Detailed description can be found for each of the pilots, including a context of pilot challenges, pilot objectives, and their innovations. The pilot's descriptions consist of the main information given in the deliverable 7.3, and there are the following information. There is a general area characterization, pilot scale, land uses, it means crop types, then also current challenges of the pilot, then major agricultural and environmental projects, stakeholder requirements, current scenario, envisioned scenario, expected benefits, and stakeholder description. And last but not least, there is also the interactive map delimiting the pilot area. Then at the bottom of the pilot web page, you can find a discussion panel. And that brings us to the creation of an account for the SIEUSOIL Hub, because without that, users cannot create a post in a discussion and cannot use another important part of the SIEUSOIL Hub, which is the map client. So let me go up on the SIEUSOIL Hub, and in the main menu, you can see a sign in button. So let's click on it. And if you already have an account, it is necessary to put here the credentials. If not, you can click this button and create your account. So as you can see, you need to fill in all the information, and after the first login, you will be prompted to change your password and select a verification question in case you forget your password. So I've already created an account for the SIEUSOIL Hub. So let me sign in, please. And after you sign in to the SIEUSOIL Hub, you can see at the very top of the SIEUSOIL Hub dark panel. This icon is the main menu of the library portal of the SIEUSOIL Hub, and it provides you an option for editing your account information and also to log out from the SIEUSOIL Hub. So if I click my profile, then go to account settings, I can modify the information, I can modify my personal information, also check portal information and change my password. Okay, let's go back to the SIEUSOIL Hub. In the main menu, you can also see tools and applications that are available at SIEUSOIL Hub. About the tools, we will speak a little bit later. And now I want to show you a map. Just a minute, please. In the map client, you can visualize available map compositions and also data sets that are available at the SIEUSOIL Hub. So let me, for example, show you the SIEUSOIL Hub training composition and how it's visualized. You can switch between the layers. And now I need to go back to my presentation. Sorry, that was wrong button. And I want to talk more deeply about HS Layers NG, which is the map client you've already seen. The HS Layers web application doesn't only allow data to be visualized. It is also possible in the presence of another components to publish your own layers or compositions, or to add your own layers to existing compositions. And because we would like to get you involved in the creation of map compositions and the use of these tools, we will first show you what components are behind this possibility of sharing and creating data, and then we will show you how. For the publication of data sets, the creation of map compositions, and the creation of metadata, SIEUSOIL Hub offers its own technological line in which, as I've already mentioned, several tools are involved. And these tools are otherwise open. All these tools are separate, but in order to publish the data, it's necessary to look at these tools as in one complete line. In this slide, you can see how these components communicate with each other. You can publish layers, compositions, or just view them online using the aforementioned HS Layers NG web tool or the QGIS desktop client. Then there is a component that is not visible to the user. It is the Layman or layer manager, to which we supply geodata, and it processes it into the OGC standard mapping services like WMS or WFS. Along with the creation of geodata, we also create metadata, which is published in a metadata catalog, MITSCA. These components, which I've just talked about, are covered by the SIEUSOIL Hub, in addition to Qgis, which is a desktop client. On the picture, you can also see a connection between all components. And now I would like to show you both ways of creating and publishing data. We will start with web mapping application HS layers, and then we will show you how to publish the data you have stored on your computer to the web from QGIS using the QGIS Layman plugin. So just a moment. Yes, and I am afraid I need to stop sharing and start sharing again because I didn't allow to play a sound while screen sharing. So just a moment, please. And here we go. Now it's a time to show how to store and load layers, create layers, edit layers, compare multiple visualizations at once, load and share map compositions in the web mapping application. As we are going to work with the web-based application, you don't need to install anything to your computer. You only need to log into the SIEUSOIL Hub, which gathers all necessary tools. So let me sign in here. I will put my credentials here. And here we go. And now we can go to the map directly from the main menu. Here you can see a web mapping application and a toolbar at the right side. I will just quickly go through all tabs, but really it will be a quick overview because we will talk about all elements of this web application more deeply very soon. So this is a layer manager, legend. This element or this tool measures distance or area at the map. This is a list of available web compositions, data sources. This is an information panel. This button prints a map. This one shares a map. This is for saving of the current map composition. And in the additional panel, you can see a feature table and draw tool. Before we start creating new layers and adding new layers into the catalog, we need to log into the catalog or Layman. You can do it right here. And as you can see, here is a login to catalog button. You might be confused that there is a login again because we have already logged in to the portal in the beginning. But you have to remember that Layman is a different application than HS layers. We don't have to really log in. The only thing we need to do is to authorize HS layers for access to Layman storage. As you can see, I don't need to fill in any credentials again, and I will just authorize. Let's focus on data sources and layers and its selection, which is hidden under this data sources panel. At the very top, you can see 3 tabs. The first one is data catalog, second one is URL, and the third one is file. The first tab, Data Catalog, is connected to Metadata Catalog, Metska, and Layman. Here you can see quite an extensive list of available data layers. For faster orientation, you can filter the list, and now you can see that only soil-related layers have appeared. By clicking to this box, you will see only your layers. So if I delete a soil, I can see a list of layers that I've created so far. Now let's move to the second tab, which allows us to upload WMS, WFS, KML, GeoJSON, or Qgis map server. So I will, for example, select WMS, copy a link to the service, and as you can see, we have 13 available layers in this WMS. Unfortunately, you can see it in the Czech language, but I can translate it for you. It's the first 6 layers I dedicated to index of soil moisture in last 6 years, and the rest is dedicated to moisture of soil surface also in the last 6 years. So I will, for example, select the 2020 and add it to map. Now you can see both layers have displayed in the map window, and what I can do now is to use the third tab and upload some shapefile. So in addition to shapefile, you can also upload a KML or GeoJSON. But I want to upload shapefile because I want to see what was the soil moisture in Rostenice fields. So I have chosen the files. Now I need to put the name. Well, I will put here Rostenice training with today's date. Here is an abstract. And in this step, you can choose whether the read access rights and write access rights will be public or private. I will leave the read access rights as they are, but I will switch write access rights to private because I don't want anyone to edit my layer. And now I can edit into the map. And here we go. Here is the third layer. And what I can do now is to delete it and upload it not as a WMS, but as a WFS. We can check the data catalog, go to data catalog, tick only mine layers, and we can see now that Rostenice training has been stored into the Layman. And by clicking on the Add to Map icon, you will see that you have an option to upload it via WMS or as a WFS. So I will click on WFS, and now the created layer is in the editable format. Now we will show how to create a brand new layer. For this purpose, we will use a draw tool. So I will click on the icon. You can choose from 4 feature types, which is a point, a polygon, line, or circle. This button is for selection of features. So I will select a point, but be careful because now we are drawing to Estimator training layer, and in case you don't want to edit it no more, you should create a new drawing layer. So let's add new draw layer. We can name it like this, and again you can choose whether whether the read or write access rights will be private or public. So I will set the write access rights to private and press OK. And now you can see we are drawing to the brand new layer. So I will put here some points. Those new points are automatically synchronized to the Layman. That means that all points we have just created are already stored in Layman. You can simply check it in the data catalog. And yeah, we can see that draw layer test, which I've just created, is here. Okay, as we have added some data to the map and created this, if I can say, this nice map composition, we might now want to save this as a composition to the server for later use, or you will want to show off your composition to others. For that purpose, we can click the Save Current Map button. You can put a title here. I will put a name here. Also, I need to fill in an abstract here. You can put some keywords. So, for example, soil, moisture, index, rostěnice, farm, and so on. And you can also select whether this map composition will be publicly or privately readable or editable. So I will leave the read access rights public, write access rights private. And you can also select what layers will be stored into the map composition. So I will only untick this OpenStreetMap, and we can press next. Here are some metadata about the creator, but I can skip this step, and finally save the map composition. And as we can see, the composition was saved successfully. What is really important to mention is that the metadata of all compositions that you save to Layman are automatically registered in Mitska metadata catalog, which means that this is way you can create a great community data store. For browsing the existing data or map compositions, there is a compositions panel, It's some way similar to Data Catalog tab, but this time we are not browsing the map layers, but map compositions. And I want to show you a few more options, which is the possibility to merge compositions. So here is the compositions that we've created, and we can, for example, add another composition from the list of available compositions. So I will, for example, add a Korean land cover, and here is a question if you want to override existing map. If we click continue, this map composition will disappear and it will be replaced by the Korean land cover. But if we click merge compositions, all the layers from the previous map compositions that we've created and from the Korean land cover. And the last thing, what I want to show you is that you can share your map compositions on the social media. So you can use share pure map link or permalink, and you can share it by clicking on this. So we've just shown how to load layers, create data, and save map compositions. And this is something that you can do right now. Now let's look at how to publish data to SIEUSOIL Hub from QGIS using the QGIS Layman plugin. At this point, I assume you already have the QGIS Layman plugin installed in QGIS. Its installation is not complicated at all, and its procedure is described step by step in the document we have prepared for you and which I will share with you later. Now we will gradually show you how to load the layer on the server, and then we will create a map composition, which we will also publish on the server. For our training, I have prepared two vector layers. First one shows the rate of field potential of the selected fields in Rostinice farm, and the second one displays the borders of these fields. To put the data into context, I loaded an orthophoto, which is a raster format, as a background map. So the Layman QGIS plugin can be found here and also in the plugins. As you can see, here is a Layman QGIS plugin as well. So first of all, we need to log in. Which means that we need to choose the Digital Innovation Hub where you want to upload and download data. So I will select hub.sieusoil.eu, and before you log in, you need to be registered to the hub to have an access to it. And now I am going to authorize the Layman QGIS on the portal. So let's click login. Okay, so we are logged in and authorized, and let's first try publishing layers to the server. This is possible by clicking red arrow button, which you can see here on the toolbar panel. And because the plugin can only publish vector data from QGIS, you might notice that only two layers are displayed in the dialog box. Now we will select a layer that we want to upload to the server. I choose, for example, a layer displaying the field borders. Mark the layer and click the button Export Layer. I will close the window, and let's now see if the layer was uploaded to the SIEUSOIL Hub. You already know this environment very well, and as you can see, I am signed in, and now we will go to the map. And if the layer was loaded successfully, then we should find the currently loaded layer in the data catalog. So let's see. Yeah, and what we need to do is to log into catalog first and authorize. Yeah, and if I select only my layers and go down, I can see Rostinice test fields layer right here. And what we can do is that we can display the layer in the map. So I will click Add to Map button, then select, for example, WMS, and the layer was uploaded and also displayed successfully.
Now let's go back to QGIS and show how to create a map composition from existing thematic layers. For that purpose, the QGIS Layman plugin offers to you this icon. So let's click on it. And as you can see, the current map composition window is empty. Therefore, we will create a new one. So let's click this button. I will put a title of the composition here, which will be, for example, SIEUSOIL training composition. I can also put here a description. And click Create. At this moment, the window offers you all existing layers that are uploaded to QGIS. So I will, for example, select Rostinice test field potential layer and Rostinice test fields. What I can also do is to choose a server type. So you can choose between WMS and WFS. So let's put WMS for both layers. And what you can also do is to edit metadata. Editing metadata can be done here, but I don't want to change anything, so I will close the window. You can also set permissions for this map composition, but I am satisfied with reading and writing rights, so I will close this window, and the last thing that remains now is to save changes. So let's click on it. And as you can see, all layers has been imported into the map composition. And now the very last thing that remains is to check whether the map composition has been successfully uploaded to the server. So I will click on Map Composition button. And as you can see, the SIEUSOIL training composition is available in the list of compositions. So let's click on it, then click Open. And as you can see, both layers has been uploaded to the map composition and displayed in HS Layers NG. So this is it. This is the end of QGIS Layman plugin guide.
Okay, let me jump back to the presentation, and I will share with you few more slides. Yeah, I wanted to mention that in the frame of task 1.2, there was the analysis of the 148 soil-related information sources. It's only 9 Chinese data sets, 15 European data sets, 28 joint China and European data sets, then it's 16 pilot-related data sets and 80 local data sets. And all 148 information resources that were identified as crucial for SIEUSOIL are described by metadata and can be found in the metadata catalog MITSCA. So this is all from my side. Thank you very much for your attention. And if you have any questions, I will happily answer them. Thank you.
Thank you very much, Hannah, for your presentation. I request colleagues whether you have some questions. If no, please may I request Maria about continuation of this training.
Hello. Good morning, everyone, and thanks for attending to this meeting. For those that this is their first day, I would like to make an introduction, and I'm gonna pass the floor to Angela and George, who are the people who are generating products that the DSS is holding right now. So let me share the screen. Oh, sorry for the date. It was Monday. So the aim of the DSS is integrate the output from other work packages into different components. It's been thought the precision agriculture component, which is the scale, the right scale is the field or farm, and the target user would be farmer and agronomy consultant. In this component, this component is holding the work package 4 products. And on the other hand, we have the land suitability component, which is being thought for regional scale, and policymakers and regional authorities are the target user. In this component, we have it's holding the work package 5 products, and my colleagues after this presentation are gonna explain more about this. The design and development and the testing of the DSS has been done in collaboration with other partners, and potential users. So we have been holding a lot of meetings and semi-structured interviews with external people from the project too, like people like consultants, farmers, and technicians. We have been collecting impressions and main conclusions and transferring these conclusions to the team, to the development team. Today is here Ifigenia. Maybe she wants to make some comments, but we have been holding those meetings in order to get the user's requirements in the 2 components of the DSS. In this case, I would like to all the attendants of these meetings to collect their opinion too, because we are in the framework of the Work Package 7, which is very important for us to know what they think. And in this case, I don't know if some Work Package leaders are here. I think they don't, but we will require them how their products could be integrated in either SIEUSOIL Hub or SIEUSOIL DSS, because we need to put together all the outputs of this project in some of our platforms that you are going to see. So now I would like to pass the floor to Angela Guerrero. She's in charge of the presentation of the first component. So, Angela.
Great, thank you, Maria. Good morning, everybody. Thank you for coming here. As Maria said, I will be presenting the SIEUSOIL precision agriculture component. So I'm going to share my screen now. Screen 2, yes. And I'll start with the presentation. I assume everybody can see my presentation now.
Yep.
Is that correct? Perfect. Great. So welcome. I'm part of Ghent University, and I'll be presenting you this component. So basically, in the slide, we have the workflow. This workflow of the service is divided into two main parts. On one hand, we have the the whole soil scanning with the multi-sensor platform, which we are going to see in a while, and the development of the prediction models for soil properties, and also the crop growth data. On the other hand, we have the mapping of these soil and crop parameters, and by data fusion techniques of these variables, the management zones map is developed. Finally, with this management zone map, several variable rate maps or recommendation maps can be developed for different management in the field. So what is the aim of this DSS tool? The decision support system has an aim to provide to the farmer a tool to, first, to visualize the status of the field in relation to crop and soil parameters, but also to provide to the farmer the variable rate maps or the prescription maps that can be used in variable rate machinery. Let's say, for example, fertilization, seeding, manure application, irrigation, and so on. So the DSS works as a tool where the farmer or the advisor has access to the information of the service provider, and he also has a direct product that can be used in his own field management. Great, so this is the multi-sensor platform. Our multi-sensor platform is composed by, well, the structure, but it has three main sensors, which are the near-infrared sensor, which is located on the top of the multi-sensor platform, but also it has a fiber optic. This fiber optic goes inside the soil, top soil. He's measuring about 15 to 20 centimeters, and it has a subsoiler, which is making a trench while he travels along the field. The multi-sensor platform also has a load cell sensor here and a depth sensor attached to this wheel. Of course, it has a GPS and it has a data logging system. And it is connected, the platform is connected to a tractor with GPS with auto steering. So the idea is that the tractor is well attached to the platform and is driving it along the field in parallel lines between 10 and 12 meters. And the fiber optic and the near infrared sensor is capturing soil spectra, and the data logging system is recording this soil spectra, the load cell reading, and the depth sensor. And with the GPS location, he is creating a full database of every second in each point. So every second we have one reading of all the sensors, which means that we will have a lot of data and a high resolution data to work with. What happened with this data? So for the soil spectra, we also collect some random samples in the soil in the field. And with these random samples and with the full soil spectra collected along the field, then we create prediction models. So the prediction models are developed for these 9 main parameters. We have organic carbon, pH, potassium, magnesium, phosphorus, sodium, calcium exchange capacity, and moisture content. So we are able to, with the soil samples and the random samples, we are able to create calibration models for the field and actually the farm, and we are able to predict new properties in the same field or in the same farm. So the idea of the service is we go with our sensor and we collect this information for some fields, And then when you need, again, this service, then we already have the model for this farm, and we are able to predict these soil properties in high resolution. Great. What is the service itself? The service is a system which would be a service for the farmers or the advisors under a service provide business model, where the farmer pays some euros per hectare. So the products are the predicted soil properties and maps, crop NDVI, the maps of management zones, and the recommendation or the variable rate maps. This price of the produce would vary depending on the package of product, the country, and some other variables. And the idea is that Kent University will soon establish a spin-off company to sell these products, but this can also be extended to another countries as daughter companies. Great. So I'm going to go to the tool now. So when you go, oh wait, I'm not looking at you now. Great. I hope you can still see my screen. Yes. So when you open the tool, then you are asked, of course, your credentials. After you logged in, you will have this main screen. So your main screen will have all the fields in your farm or the fields that you are managing listed and some images. The interface is really, really simple and user-friendly. If you open it here a little bit, then you can read what are the options. But the main, one of the useful tools is the user guide, because if you click it, then you will have a PDF just explaining you how to do things. And this is really helpful. Great. How do you start? So you have, let's say we don't have any fields, so you are going to create one of your fields. Then you are here in create parcel. And when you click there, then you have the latitude and the longitude. I have one here so you can see. I'm going to paste it. This one. And when you zoom in, then you can see more or less the area you're looking for. And the idea is that you, with your click, will create the boundary of your field. Let's make a kind of circle over there. And there you go, you have your parcel. What is the main thing here? That you can index all the data from your field. So you have your name, the crop type that you are going to grow, the sowing date, the harvesting date, the soil type, and you are able to choose the soil composition if you have it. Great. After you have all these details, then you click on save. And if you go to your main website, then you will have your fields over there. If you click in one of the fields, then you will have all the details that you just have saved in the previous stage, and you will have the boundary of the field. Good. So now let's see some of the maps. So the idea here is, in this overview of each of your fields, you have three main clusters. The first one is the crop monitoring, the second one is the soil monitoring, and the third one is the management zones. So for the crop monitoring, we have NDVI, for example. Then you will see some NDVI maps with the legend, of course. And what it is interesting here is that you can see that there are plenty of dates, which means that this tool can also help you to have an historical track of your field, of the behavior of your field. And that is actually really, really useful for farmers. You also have, for example, yield maps. You will see that there are also some other maps, so it's historical. You will always have the units in the legend. And for example, let's go to the soil monitoring. So based on the multi-sensor platform, we were able to have these maps and high resolution maps. Then, for example, this is the organic carbon map. It takes a while. Good. So this map was developed after doing the whole calibration and prediction process that I just mentioned. And here you have all the map with the units. And what is also interesting in this tool is that you have this legend down here. And this legend tells you that it is like an insight of how is how are the values of your field. So they might be optimum, fragile, or bad. And then you have like a reference value to see if there are some things wrong or not. Also, it is important to mention that we have 2 buttons in each of the maps. So if you want to export it in PDF, then you just click this one and you will have exactly the information you are looking at right now. But also, if you want, you can download the raw data, and if you see, it comes up as a TEF file. And this is, of course, geolocalized, so you can use it in any GIS tool to make some order management and so on. Great. So let's see, for example, another map. Here we have pH. For example, as long as you have a date here, then there will always be data. It might take a while to load, but there will always be data. If you don't have any date here, it means that the information is not there. Great. So as you can see, well, you can see all the maps, sorry. And also the advice will change according to the soil property, of course. Great. And then we have our third cluster here, which is the management maps. So for the management zones, you will see that after making the data fusion between soil and crop properties, we obtain this map of potential fertility zones. So what we have done is to apply an algorithm of K-means clusters, which allow us to condense all this information into 3, 4, or 5 main clusters. In this case, the map that you are looking at, it is classified into 5 zones. And then the potential, being high, medium, or low, is developed either by having the yield, the historical yield data, if it is available, but also in meetings held with the farmer, because the farmer, of course, knows their fields very well. But then they are able to evaluate a little bit in a bigger scale what is going on. In the legend here, we have also the maps or the variables used for developing these management zones. So you will understand also why these management zones are like that. This is really useful for the advisors, which they can also advise on, for example, amending the pH or other parameters, and not only for the management, for the upcoming management as fertilization or so on. Great. This map, well, is really useful, but one of the main results of this tool is that you can actually download the variable rate map. So this, for example, is an experiment that we have developed in that specific field. And what we do is to split the field into some variable rate fertilization doses. But what it is interesting here is that this map can be downloaded as shapefile. So if you click now in the raw data, you will, instead of having a TIFF file, you will have a ZIP file. And if you open that ZIP file, you will have a shape file with all the metadata here of that field, of that map. And that shape file, it is actually a standard format, which allows the farmer or the advisor to download it directly and put it into the machine, or like in the system, like in Trimble or John Deere. And then you can convert this shape file into a prescription map, which is directly the product that the farmer wants. So he doesn't have to be aware of how the coordinates work or how those work or anything like that. The map is ready to use. This can be used for fertilization, pesticide application, seeding, irrigation, and so on. This is actually one of the main outputs for the farmer. Great, I think that's all my presentation so far. Then I will go back to Maria. I'm not sure if someone wants to give some other insights over there. Stop sharing. Maybe Eugenia, if she wants to say something or something. Great, no, okay, Maria, then.
Sorry, I was trying to find the mute button.
Okay.
No, pretty much I haven't a lot to say since you did an excellent presentation. I would like to say a few things that Maria said before about the feedback that we have received as a technical team in order to make modifications on the platform. I think that the task leaders of the co-production, co-creation phase did an excellent work, because we had several feedback from their side in order to improve the functionalities of the platform, and it seems that they really put a lot of effort on trying to find what is best for both of the components of the Dss tool. And we have made the modifications based on the discussions and the meetings that we had with Maria, Angela, George, Thomas, and all the involved parties with regards to the platform. And all of these changes have been described in their respective deliverable.
Okay, thank you, Virginia. And George, I think it's your turn.
Yes, thank you, Maria. I'm going to do a small presentation about the land suitability analysis tool. I'm sharing my screen. Now, can you see my screen?
Yep.
Yes. So the land suitability analysis tool is under the work package 5 of SIEUSOIL, and the key points of land suitability analysis that was performed in order to have an idea is that land suitability analysis was performed according to the FAO framework. It is applicable to pilot areas at regional scale, and right now we've finished with Flanders in Belgium. We are finishing with Somogy in Hungary, and we are working on Hengshui in China. The input parameters to the model is soil, climate, and topography parameters. The first step is to score these input parameters, meaning normalize, standardize them, receiving values from 0 to 1, okay, based on threshold values. The land suitability calculation is performed using a weighted linear combination equation, like the one right here to the right. Weighing factors were calculated using the analytical hierarchy process by Sati, and we were based on local experts' opinion that they have provided us with the priorities of each parameter. The output maps of the model is land suitability score maps with values from 0 to 1, and also FAO classes, as I'm going to show you later, like the ones that you see in this table. We have S1 class, S2, and S3 classes, which are classes suitable for the specific crop, And of course, we have N classes, which are either temporary, unsuitable, or permanently unsuitable according to the score that they receive. This is the general outline of the procedure. This is a flow chart that shows the algorithm of the land suitability analysis tool. We have the input parameters. We have two phases in calculating different kinds of scores and calculating the final output land suitability score, of course, in the form of maps. As an example, this slide shows 3 maps of the input parameters. They are sample maps. On the top left is a pH map of the area in Flanders, specifically. On the top right is a mean temperature map in the same area. And of course, for the topographic parameters, we used slope as the main topographic characteristic of the area. The output of the model was, as I said before, 2 kinds of map. On the left, you see a land suitability score map for Flanders and specifically for wheat, and the receiving scores from 0 to 1. And on the right, after the classification of the FAO classes, we produced a map of land suitability classes. As we see in this map, there are 3 suitability classes, S1, S2, and S3. And specifically for Flanders and wheat, we had no unsuitable areas. Another very important and useful map that is produced is the limiting factor map. This map is, of course, again for wheat and Flanders, where with different colors we can see which parameter has the lowest score, is the most limiting parameter. For example, the red color is pH. Most of the area in Flanders, the lowest score goes to pH. And of course, there are parts in green, for example, is the mean temperature that is the limiting factor. Quartz fragments is the blue color, and of course CC, soil organic carbon, and slope, but in a much smaller parts of the area. Now I'm going to show you the land suitability analysis tool, the platform that was produced in collaboration with all the partners in this work package. And let me change my screen. Sorry. Wait. Right. Can you hear me?
Yes, we can hear you.
Yes.
Yes.
Because, sorry, stop share, yes. Share screen, and let's go to the LST platform. The address that you, it's in the slide, the address is right here, so you can visit it anytime that you want. The capabilities that this tool gives you is to add data. So you go to the Add Data button, and here you can see that you have data results from land suitability analysis for potato and window width in Flanders. The input parameters that we used in the procedure, that are used in the LSA, in the land suitability analysis. And of course, you can do some zonal statistics, as I will show you later, explain later. But let's start with the result for land suitabilities. Let's choose land suitability for window width. The analysis that we ran was not only for current situation, but also for 6 scenarios, soil improving cropping system scenarios. And we chose 4 different management measures, which is crop cover, conservation tillage, crop residue management, manure application, and in order to see how the soil quality improves in 100 years from now. But let's start with the current situation. Here you have the land suitability score map, values from 0 to 1, and also the limiting factors map. So for window weight in Flanders, this is the land suitability map, score map, receiving values from 0 to 1. Okay, you can clearly see the areas with high scores, and the rest of the area. Of course, the score is still high, but it's smaller than the dark green areas. And you can also add the limiting factor. Let's go here. You can see the limiting factor in the area. It's for window weight again in Flanders. And another capability that the tool gives you is you can superimpose maps using this button on the screen. You can drag this line to the left or to the right, and you can see now which parts of the area with a certain score, land suitability score, which is the limiting factor by moving the line to the left and to the right. This helps a lot, because if you have an area with a low score for land suitability, then you can use the limiting factor map and see which parameter is causing unfavorable conditions. And let's remove them all. The same you can do with the 6 scenarios and see which is the future, let's say, land suitability score or the limiting factor as well. And another capability is the zonal statistics estimator. Zonal statistics, first you have to add, let's see, current situation, land suitability score. First, you have to copy the name of the layer that you want to use as an in the zonal statistics. Copy it, insert it here. Sorry, I have already inserted it, but then Sorry. I have already drawn a polygon. Click to draw polygon. Let me first add some data, of course, here. And then do the zonal statistics. Then you can draw a polygon in the area that you're interested. Okay, and the platform is going to calculate land suitability, average suitability values, and other descriptive statistics in this area. So choosing done and then run analysis. What's on now? Here it is. The polygon that I draw, and these are the zonal statistics for land suitability in the area of your interest. That's all the information that the LST is providing and producing. Now that's all from me. I don't know if you have any questions that we could discuss. Okay, so Maria.
Thank you, George. Okay, so I don't know if someone has any comments, questions. Okay.
Maria, thank you very much. Thank you to all your team for your presentation. Please, colleagues, this presentation is recorded. I suppose that today I will resend to all our SIEUSOIL Communa today record, and I think that our colleagues can use this presentation for their learning and for their, I think, knowledge improvement in area of SIEUSOIL outputs. Please, thank you very much, Maria and your team. Thank you very much, Hannah, for your presentation. And from my side, that is all, and presentation is complete.
Thank you very much, Jaroslav, for organizing this.
Thank you very much.
Thank you.
Thank you.
Thank
Have a nice
you.
day. Bye-bye.
Thank you, colleagues.
Bye-bye.
Bye.
Bye, everybody.
Bye. Thank you.
Bye.